2024 paper. No, 2020 paper. Okay. As shown in the figure, PAE and PAE mean this straight line, PBF. Okay. Two tangents to the circle with center O drawn at the points A and B. A and on the B. Okay. The straight line PF lies on the circle's circumference at B and this line at A. BC is the diameter. Okay, thereafter copy the figure onto your answer script and join OA. Okay, we need to join straight line OA. Let's connect them first. OA. Okay, we know that one theorem, radius is perpendicular to the tangent. Perpendicular to the tangent at that point. Show that OAPB is a parallelogram. Oh, sorry, is a cyclic quadrilateral. Okay. OAPB is a cyclic quadrilateral. Cyclic quadrilateral means we know that in a cyclic quadrilateral, how can we determine this one as cyclic quadrilateral? Sum of opposite sides are equals, opposite angles are equals to 90. That is the only condition to check whether that is a cyclic quadrilateral or not. If these two sides, sum of these two angles are equals to 180 and these two angles are also equals to 180, that can be concluded as a cyclic quadrilateral. That's the thing we are going to show over here. Okay. That means we already know that we connected O and A. OA is a radius. So radius and tangent are parallel. This one also parallel. This one also a radius because BC is a diameter. That means OB is the radius of this circle. So then after tangent and this radius are parallel, perpendicular. So this one and this one, opposite angles of a quadrilateral, are equals to 180. 180. So let's write that relationship first. Okay. OAP equals to 90, comma OBP also equals to 90 because you should write the reason. Radii is perpendicular to the tangent. That's the only reason we need to write over here. Okay, we need to write over here. This one and this one are 90 degrees. So that means sum of these two equals to 180. So we know that remaining two angles, okay, if these two angles are equals to, sum of these two angles are equals to 180, other two angles, cyclic quadrilateral or not, since it is a quadrilateral, sum of all angles are 360. Now we already know that sum of these two angles are 180. So sum of remaining two angles are also equals to 180. Let's write that one as well. AOB plus APB equals to 180. Why? You should write the reason clearly here as well. Because sum of remaining two angles in a quadrilateral. Okay, I'll repeat again. What I did was to show these two are, okay, we need to show this as a cyclic quadrilateral. The theorem is to show this one as a cyclic quadrilateral. Opposite angle should be equals to 180. We know that these two are equal because radii is tangential to the tangent. No, that means these two are in perpendicular relationship. Similarly, this one as well. By that, we determine opposite angle sum in this manner equals to 180. So that means since it is a quadrilateral, other two other two remaining angles sum also 180. So our condition was satisfied. No? Condition was satisfied. That means then after finally you should write your reason. Okay, I'll write the reason here. Opposite angles of a quadrilateral. If opposite angles of a quadrilateral are supplementary angles. Okay, supplementary angles. We know what it means by supplementary angles. Supplementary angles. Therefore, this is a cyclic quadrilateral. This is a cyclic quadrilateral. Okay, I'll repeat again. Just note it down clearly. If opposite angles of a quadrilateral are supplementary angles, opposite angles of a quadrilateral are supplementary angles, this is a cyclic quadrilateral. That's all for your reason in first case. Okay, to write this you will get 1 mark. To write this you will get no, for here 2 mark, 1 mark, 1 mark. Totally to show this you will get 3 mark. No, 3 plus 1, 4 mark. Totally 4 marks to show this one as a cyclic quadrilateral. Not a difficult one, very easy basic theorem. Okay, in the second part, join CA and AB. That's the first one. For each question, okay, for the first question, we drew a diagram. Similarly, for second one also, just drew a diagram before starting to do the question. Don't do everything by using a same diagram, okay? In previous one, you just connected them, but you don't want that one now. No, draw a new diagram. CA and AB. Okay. Okay, then the data we need to show that, and OP as well. Okay, we need to connect OP as well. Then after I'll read the question. CAAB, show that ACB, this one is equals to POB, POB. Okay, that's the thing we need to show. Okay, ACB equals to POB. We need to show that. Okay, we can easily show that because look at this. These two are equal. No, think about the midpoint theorem. Okay, think about the midpoint theorem. By using midpoint theorem also, you can show that. And thereafter, second one, EAC. EAC. This one equals to OAB. OAB. OAB means we need to connect it again. OAB. These two are equal. Likewise, we need to show two such relationships. Think about it. Okay. To show the green color one. Okay. First, the green color one. Just think about it. I'll explain the theorem which we need to use. Think about this AB. Okay. Think about this AB. This is subtended on this triangle subtended on the circumference and creating a circumference angle. The circumference angle is half of this midpoint angle. Okay, the circumference. Think about this chord. This chord is creating a triangle which is subtended on the circumference. So this angle, that is half of the triangle subtended on the midpoint and creating this total angle. We know that this total one, okay, this total one would be bisected by this one. We know that theorem. We know one theorem that when you drew two tangents, okay, two tangents, and when you connect them, okay, they will create some angles. Now, create some angles. Okay, when you connect the intersection of tangent and intersection of those two radius, that means at midpoint, when you connect midpoint and intersection of those two tangents, that will bisect this angle into two equal portions and this angle also into two equal portions. Okay, We know that that is a theorem. Okay, that was a theorem. What was that? Okay, I'll repeat again. There are two tangents. When you think about these radii, okay, these radii are parallel to the tangents. And next theorem what we've studied was when you connect midpoint of the circle and intersection of those tangents, that will bisect this total angles into two equal portions. That's the theorem we need to use here as well. Okay, I'll write that clearly. First of all, I'll write AOB. AOB is equals to double of ACB. Okay, AOB. AOB. The angle. Okay, by using this chord, angle subtended on the midpoint, that is double of angle subtended on the circumference. Okay, you should write the reason as well. Here you can write the reason as central angle is double of circumference angle. Okay, circumference angle. Then after we just equalize them. Then after we can write this total one. AOB. AOB can be splitted into two equal portions. Okay, two equal portions. What is our AOB? This one. This total that is splitted into two equal portions. So I'm going to write AOB as, okay, this total AOB is splitted into two angles. Okay, because intersection of tangents and midpoint, when you connect intersection of tangents and midpoint, that will bisect this total length. So we can write half AOB, which is equals to half AOB. That means this angle, which is, no, wait a minute, half AOB, POB, half AOB equals to POB, half AOB. Just clearly understand this. I also a little confused in between. What happened was this total one's half is equals to this. When you split this total angle into two equal portion, one of this occupied by this POB. The reason, what is the reason? OP will bisect AOB, because we know the reason. Okay, it's enough. No need to write the total theorem. It's enough. OP will bisect this total angle. That's the thing you should write. Okay. If you know the theorem only, you can show this. If you don't know, you cannot show this. No. So no need to write the total theorem here. Then here AOB. We just showed AOB equals to half AOB equals to POB. Then finally AOB. In the first one, instead of this AOB, I am going to replace that by 2 POB. 2 times POB. If not, think about it. Instead of this one, I'll write this relationship something like this. Half AOB equals to ACB. Okay. This one's double this. So similarly, its half would be like this. Its half would be like this. That's what I'm going to write after here. Half AOB equals to ACB. And we know one more theorem, that half AOB equals to POB as well. According to our second statement, half AOB equals to POB as well. So finally, therefore, ACB Theorem is clear, but the wordings are very important. I also made many mistakes while doing the question. Think about it. This is the angle subtended on the circumference. This is the angle subtended on the center. So that is double of circumference angle. Then we know that intersection of these two tangents, and when you connect the midpoint, that will bisect this total central angle. So likewise, we just denoted our second one as well. Then after half, I'm going to divide both of them by 2. Half AOB equals to ACB. We already know that half AOB equals to POB as well. No? So finally, this one and this one equal, this one and this one equal. Therefore, according to axiom 1, I hope you remember, in grade 9 you have studied axioms. If this one and this one equal, this one and this one equal, the third party relationship also possible. ACB and POB are equal. That's the thing you should show over here. The question they asked was, you should show ACB equals to POB. Last one also, we cannot derive that by using theorem only. You should use your brain as well. Look at this. We need to show ECA, this exterior angle which is equals to OAB, this interior acute angle. Okay, for that I am going to use two theorems. We know this tangent and the radii both are in perpendicular relationship. Think about it, perpendicular relationship. This tangent and radii are in perpendicular relationship. Similarly, think about this. This triangle on the semicircle triangle. Okay, when a triangle subtended on the semicircle, that will create a right angle as well. Right angle as well. The thing is easy, not difficult. I'll repeat again. Tangent and this one are perpendicular. That means EP perpendicular to OA, because tangent perpendicular to radii, perpendicular to radii. Then after that means that 90 degrees. Okay, this one and this one are perpendicular relationships, so I can write EAC plus this exterior angle and this angle. Okay, think about this. If this is perpendicular, that was splitted into two angles, this angle and this angle. Sum of these two angles equals to 90. That's the thing I'm going to show. EAC plus this is CAO equals to 90. CAO equals to 90. I'll repeat again. Try to understand this clearly. Tangent and these radii are perpendicular, so this angle and this angle both together will give you the 90 degree. This 90, okay, don't think about the red color one. This 90 is splitted into two angles, so sum of those two angles equals to 90 degrees. Then after, similarly, think about this. This is semicircle triangle. Semicircle triangle will subtended on the circumference at 90 degree angle, right angle. So ABC is a semicircular triangle. Semicircular triangle. Semicircular triangle. That means that will subtended on the circumference at 90 degrees. So that means, think about this. This one was splitted into two angles. So sum of this angle and this angle equals to 90. That's the thing I'm going to write hereafter. I'll write that one. So think about this. I'll use some different colors. This angle and this angle. Okay. Think about the light blue color ones. This one plus this one equals to 90. This one and that one equals to 90. By that, we can write another relationship. Okay, that means this is right angle. This is a right angle. So this angle plus this small angle both together will give you 90. So I'll write CAO plus what is this angle? AOB. Oh, sorry, OAB. Total angle, that was OAB. Just this is extended up to here to name it. That's all. CAO plus OAB, which is equals to 90 as well. 90 as well. We just denoted this one is 90. So sum of this angle and this angle equals to 90. Thereafter this is 90. That means this one plus this one equals to 90. So finally we can write the reason as, look at the reason clearly. This is equals to 90. This is equals to 90. So that means we are going to equalize both of them. EAC plus CAO. Okay, I'll write over here. I'll write over here. Okay, EAC. I'm going to equalize this because this also equals to 90. This one also equals to 90. That's what I'm going to equalize. EAC plus EAC plus CAO. CAO equals to the angle here. Okay, this one equals to 90 also. So that means CAO plus OAB. OAB. So here we just proved. Look at this relationship. CAO, this one also consists of CAO. So both can be cancelled out. Here also sum of CAO. This one also added with CAO. We can directly subtract that one. Then finally we can show EAC equals to OAB. EAC equals to OAB. That's all for our answer in this case.